Section 1. Introduction. The importance of software quality. Software is everywhere. It powers our phones, runs our businesses, and even helps us explore space. As software's role in our lives grows, so does the need for its quality. High-quality software is not just desirable, it's essential. It's about building software that works as intended, is reliable, and meets users' needs. In 1978, I introduced a model to help define and achieve software quality. This model, known as Boehm's quality model, outlines key characteristics that contribute to software excellence. These characteristics, or quality factors, provide a framework for developers to build better software. Understanding these factors is crucial for anyone involved in software development. This essay will delve into each quality factor, explaining its significance and impact on software quality. From correctness and reliability to usability and maintainability, we'll explore how these factors contribute to building software that is not only functional, but also robust, secure, and user-friendly. By understanding and applying these principles, we can strive for excellence in every line of code we write. Section 2. Correctness, the foundation of software. Correctness is the most fundamental quality factor. It refers to the software's ability to perform its intended functions accurately. In essence, does the software do what it's supposed to do? A correct program produces the expected outputs for all valid inputs. This might seem obvious, but achieving correctness is a significant challenge in software development. Errors in code, flawed logic, or misunderstandings of requirements can all lead to incorrect software. The consequences of incorrect software can range from minor inconveniences to catastrophic failures. Consider a financial application that miscalculates interest rates. This seemingly small error could have significant financial implications for users. Therefore, ensuring correctness is paramount. Rigorous testing, code reviews, and formal verification techniques are essential for achieving software correctness. By prioritizing correctness, developers lay the foundation for building reliable, trustworthy, and high-quality software. Without correctness, all other quality factors become meaningless. Section 3. Reliability, ensuring consistent performance. Reliability goes hand in hand with correctness. While correctness focuses on accuracy, reliability ensures that the software consistently performs its functions correctly over time. It's about building software that users can depend on. Reliable software is free from bugs and errors that could cause it to crash, produce incorrect results, or behave unpredictably. It operates consistently, even under unexpected conditions or heavy workloads. Think of a messaging app. Users rely on it to deliver messages promptly and without fail. Reliability is crucial for building trust with users. When software fails, it disrupts workflows, causes frustration, and can even damage a company's reputation. To achieve reliability, developers employ various techniques, including rigorous testing, fault tolerance mechanisms, and redundancy measures. By prioritizing reliability, developers create software that users can trust to perform as expected, consistently over time. This trust is essential for building successful and widely adopted software products. Section 4. Efficiency, optimal use of resources. Efficiency refers to the software's ability to use computing resources effectively. This includes factors like processing speed, memory usage, and storage space. Efficient software performs its tasks quickly and without consuming excessive resources. In today's world, users expect software to be responsive and fast. No one wants to wait minutes for a simple web page to load or for a program to respond to a command. Inefficient software can lead to slow performance, increased costs, and frustrated users. Consider a video editing application. It needs to process large video files efficiently to provide a smooth editing experience for users. Optimizing code, using efficient algorithms, and managing memory effectively are crucial for achieving efficiency. By building efficient software, developers create products that are fast, responsive, and cost-effective to run. This efficiency enhances user satisfaction and contributes to the overall quality of the software. Section 5. Integrity, building secure and trustworthy software. Integrity focuses on the software's ability to protect itself from unauthorized access, modification, or destruction. It encompasses aspects like data security, user authentication, and system stability. Software with high integrity is secure, reliable, and trustworthy. In an increasingly interconnected world, security is paramount. Software vulnerabilities can be exploited by malicious actors to steal data, disrupt operations, or even cause physical damage. Therefore, building software with robust security measures is crucial. Consider an online banking application. It must protect sensitive financial data from unauthorized access. Strong encryption, secure authentication protocols, and regular security audits are essential for maintaining integrity. By prioritizing integrity, developers build software that users can trust with their data and rely on for secure and uninterrupted operation. This trust is fundamental for the success of any software, especially those dealing with sensitive information. Section 6. Usability, making software accessible and user-friendly. Usability refers to the ease with which users can learn, understand, and interact with the software. It's about making software intuitive, easy to navigate, and accessible to all users, regardless of their technical skills. Software should be designed with the user in mind. A user-friendly interface, clear instructions, and helpful documentation all contribute to a positive user experience. When software is difficult to use, users become frustrated, leading to decreased productivity and dissatisfaction. Consider a mobile game. It needs to be easy to pick up and play, with intuitive controls and clear objectives. User interface design, user feedback, and accessibility features all play a role in enhancing usability. By prioritizing usability, developers create software that is enjoyable and efficient to use. This focus on user experience leads to greater user satisfaction, increased adoption, and ultimately, a more successful software product. Section 7. Maintainability, adapting to change with ease. Maintainability refers to the ease with which software can be modified, updated, and enhanced over time. It's about building software that is flexible, adaptable, and easy to understand and modify by developers. Software is rarely static. Requirements change, new features are added, and bugs need to be fixed. Maintainable software is designed to accommodate these changes with minimal effort. Well-documented code, modular design, and adherence to coding standards all contribute to maintainability. Consider an operating system. It undergoes constant updates and improvements. Maintainable code allows developers to implement these changes efficiently and without introducing new errors. By prioritizing maintainability, developers ensure that software can evolve and adapt to future needs. This adaptability is crucial for extending the lifespan of software, reducing maintenance costs, and ensuring its continued relevance in a rapidly changing technological landscape. Section 8. The interplay of quality factors. It's important to note that these quality factors are not mutually exclusive. They are interconnected and often influence each other. For instance, improving efficiency might require trade-offs in usability or maintainability. Similarly, enhancing security can sometimes impact performance. Therefore, achieving software quality is about finding the right balance between these factors. The optimal balance will depend on the specific software being developed, its intended use, and the priorities of its stakeholders. For example, a banking application might prioritize security and reliability over efficiency or usability, while a mobile game might focus on usability and efficiency to provide a seamless gaming experience. Understanding the relationships between these factors is crucial for making informed decisions during the software development process. Section 9. Boehm's Model, a roadmap to quality software. Boehm's quality model provides a comprehensive framework for understanding and achieving software quality. By considering each quality factor throughout the software development lifecycle, from requirements gathering to testing and maintenance, developers can build better software. The model serves as a roadmap, guiding developers towards building software that is not only functional, but also reliable, secure, efficient, usable, and maintainable. It encourages a holistic approach to software development, where quality is not an afterthought, but an integral part of the process. By embracing the principles outlined in Boehm's model, developers can create software that meets users' needs, exceeds expectations, and stands the test of time. This commitment to quality is essential for building software that is both valuable and impactful. Section 10. Conclusion: Achieving software excellence. In conclusion, software quality is not a destination but a journey. It requires a continuous commitment to improvement, a deep understanding of user needs, and a dedication to building software that meets the highest standards. Boehm's quality model provides a valuable framework for navigating this journey. By understanding and applying the principles of correctness, reliability, efficiency, integrity, usability, and maintainability, developers can create software that is not only functional, but also robust, secure, user-friendly, and adaptable. This commitment to quality is essential for building software that is both valuable and impactful. As software continues to play an increasingly vital role in our lives, the pursuit of software quality becomes ever more critical. By embracing the principles outlined in Boehm's model, we can strive for excellence in every line of code we write, creating software that makes a positive difference in the world.